Hello, I'm Bill Kinney. This is video number 15 of my series on arithmetic, algebra, and graphing, subtitled The Arithmetic of Rational Numbers, also known as Fractions, Part 4. We're continuing to look at the example with Greg and Marcia painting a room. Greg estimates it'll take him 6 hours to paint a room, and Marcia thinks she can do it in 4 hours. We looked at how much can they paint in 1 hour, 2 hours, and how long will it take them to finish, just summarizing the answers. 1/6 plus 1/4, 5/12 is how much of the room they can do in 1 hour, 5/12 of the room, that fraction of the room. 5/6 of the room is how much they can do in 2 hours, and we also figured out that it takes them 12/5 hours, which ultimately is the same as 2 hours and 24 minutes to finish painting the room if they work together. We also looked at this part, an extension of the problem. In the context of the same room, how much of the room can they individually paint in 40 minutes, 45 minutes, and when they work together for these two different times of 40 and 45 minutes. In the last video, we saw that Greg can paint 1/9 of the room in 40 minutes. Because we took 2/3 of an hour, that's the same as 40 minutes. 40 over 60 is the same as 2/3. And he can paint 1/6 of the room per hour, multiply those two fractions, those two rational numbers, to get 1/9 of the room, as how much he can paint in 40 minutes. 1/9 of the room. How about Marcia? Same kind of calculation. She can do, well, 1/4 of the room per hour. Again, we have 2/3 hours, that is 40 minutes. Times 1/4 of the room per hour. Multiply the numerators to get 2. 2 times 1 is 2. Multiply the denominators to get 12. 3 times 4 is 12. 2/12, or that reduces to 1/6 of the room, is how much she can do in 40 minutes. She can do in 40 minutes what it takes Greg 1 hour to do. How about if they work for 45 minutes? That was another question up here. 45 minutes is 45 over 60. With a fraction of an hour, and that's equivalent to 3/4. So we would take 3/4 hours times their painting rate, Greg again being 1/6 of a room per hour. Take a second to do that calculation on your own. Maybe pause the video. All right, are you back? 3 times 1 is 3. 4 times 6 is 24, which reduces to 1/8 of the room, which, by the way, is bigger than 1/9. Just as a reminder there, he can do more of the room in 45 minutes than in 40 minutes. 1/8 is bigger than 1/9. And then for Marcia, you can move this paper. 3/4 hours times 1/6 of the room, or 1/4 of the room per hour, excuse me. 3 times 1 is 3, 4 times 4 is 16. She can do 3/16 of the room in 45 minutes. And 3/16 is bigger than 1/8. 1/8 is the same as 2/16. 3/16 is bigger. She can do more of the room in 45 minutes, consistent with the fact that she is painting faster. All right, what if they work together for these times? Quickly do that. Think about that. For 40 minutes, Greg can do 1/9 of the room. Marcia can do, let's see, what was it here for 40 minutes? That was 1/6 of the room. Why don't you pause the video and see if you can do that on your own, and then come back. 1/9 plus 1/6. Okay, you're back. We can get a common denominator of 18. 18 is the least common multiple of 9 and 6. 1/9 is the same as 2/18. 1/6 is the same as 3/18, altogether giving us 5/18 of the room. That's for 40 minutes if they work together. And then finally, for 45 minutes if they work together, Greg could do 1/8 of the room. Marcia could do 3/16 of the room. Pause the video and do that on your own. If you're back, you're seeing that the answer is 2/16 plus 3/16 is 5/16 of the room in 45 minutes. That is more than 5/18. 5/16 is bigger than 5/18. You're dividing by a smaller number there, which makes it bigger than that number there. Fractions are numbers. They are rational numbers. We can put them on a number line, as we will see shortly. I think for the rest of this video, I want to just emphasize that prime factorization, which I mentioned, it was about maybe 3 videos ago or something like that, is helpful sometimes in doing these calculations for simplifying things, especially if you have big numbers involved. Maybe if we've got something like 60 over, let's make it, I don't know, 118 times 24 over, let's say 27. If we can factor these numbers, what I'm trying to get at is it is possible to do this without a calculator. Of course, you could use your calculator to multiply the numerators and denominators to get an answer, though that fraction will involve bigger numbers in the numerator and denominator. That might be harder to factor than these numbers are. Let me go ahead and think about the prime factorizations of these things just to show you something kind of neat with this. You don't have to do this to help you simplify them, but it's kind of a nice. What's the prime factorization of 60? Well, let's see if I can do it quick here with one of these trees. I showed you this before. 60 is 2 times 2 times 3 times 5. What's the prime factorization of 24? So you can see if you can do that in your head. That's 2 times 2 times 2 times 3. 8 times 3 is 24. Prime factorization of 27 is not too hard. Try that in your head for a second. It's 3 times 3 times 3. And 118, let's see. If I divide 118 by 2, I'm going to get 59. And 59 is a prime. The prime factorization of 118 is 2 times 59. How do I know 59 is a prime? Well, it's not even, so it's not divisible by 2. It's not divisible by 3 because 3 goes evenly into 60. Also, the sum of those two digits is not divisible by 3, if you know that trick. It's not divisible by 5. It doesn't end in a 0 or 5. Not divisible by 7. 7 times 8 is 56. 7 times 9 is 63. The next prime is 11. It couldn't be divisible by that. It can't be, in fact, if you take the square root of it, you get between 7 and 8. It can't be. If it's not divisible by 2, 3, 5, or 7, it's not going to be divisible by any other prime because all the other primes would be bigger than the square root of 59. Anyway, once you've got it like this, you can cancel, as I'm doing here. These two 2's can cancel. No other 2's cancel. I guess these 3's cancel over there, or I could cancel this 3 with one of those. Maybe you remember doing this. I guess this is not simplifying as quickly as I was hoping. See if we can still do this by hand without a calculator. 2 times 3 times 5 is 30. 2 times 2 times 2 is 8. What I really got up there is 30 times 8. That's 240, since 3 times 8 is 24. 3 times 3 is 9 times 59. I would do that by doing 9 times 60 first in my head. 9 times 6 is 54, so 9 times 60 would be 540. So 9 times 59 is going to be 540 minus 9, 531. And since I've done all the cancellation I can possibly do here, I can't go any further with this. I can't reduce it anymore. There are quicker ways, actually, without doing prime factorizations to reduce this fraction, but I wanted to show you that you could do it with prime factorizations.